So since Dr. Stevens does this walkthrough with z-scores in the table, I thought I'd do this using that Rossman Chance applet for those of you that are having a hard time running the formulas. It's not cheating to use the applets. So we want to come up with, well, let's see, first off, the first question doesn't even need an applet. Our point estimate of the proportion of ears of corn that will have earworms or cornworms with worms in them is just based on our sample result. So p hat is our point estimate. And so there were 12 out of the 80. And if we make that a decimal, that's 0.15. So our p hat, our point estimate for the proportion of here, the point estimate for the proportion of ears of corn in this field that will have worms in them is 15% or 0.15. Now we're going to get a better estimate because we know based on sampling distributions, if we went out and picked a different 80 ears of corn, we'd probably get a different p hat value. So we want to account for all those possible outcomes, and we want to be 95% confident for this first one. So if you go out to that Rossman Chance applet that I pointed you to, okay, I know I'm dealing with a proportion because this is about a categorical variable. Does the ear of corn have worms in it or not? And then you just got to give the applet, oh, what'd I do? Here we go. We had 80 ears, and 15 of them had worms, and that just is just a little bar graph. And now we're going to do a confidence interval, and we want a 95% confidence interval, so you should just be able to, yeah, there it is. So there's our estimate. The lower bound is about 10.2%. The upper bound is 27.3%. So that's our estimate. That's our estimate. Now, we aren't asking us to write any kind of confidence statement or put that in context, but what we really know is we know that we're 95% confident that the true proportion of Carl's corn that'll have worms is between 0.102 and between 0.273, or if you want to change those percentages and be talking about the true percentage of corn ears that'll have worms, we'll say 10.2% to 27.3%. And now what about for the next part? Well, 99% confidence interval, the beautiful thing about the applet, it does the adjustment for you. I'm going to change my level of confidence to 0.99. Notice it's a little wider. It's between 7.5% and 20, basically 30% of the ears will have corn. 30% is getting a little high, but don't know how to go buy corn from Carl. Okay, so that's A and B. It's that easy with the applet. You just got to change, make sure you select the right scenario. In this case, we have one proportion, and then you need your X and your N. Now, the only thing that can happen, and if you go look at some of that optional assignment that I gave you, made available to you, what can happen is they might tell you p hat. So if they had told me that Carl had a earwig or corn ear problem, and we found that well, let's say they said 15% of his ears had worms, and they told you they went out and found a sample of 80 ears. See how they're not telling you the 12 in this case? If they do that to you, and I do that to you on a quiz, you just got to make sure that you find 15% of 80. In this case, it'll be 12 because nice, no need to round. If it works out, so like what if they had asked me what if they told me p hat was, 19%? Well, if I go 0.19 times 80, I'm not going to get a whole number. In fact, what do I get? 0.19 times 80, I'm getting 15.2. And of course, the applet's looking for a whole number because I can't have 0.2 ears. So it'd be safe to round down. I mean, WebAssign might be a little picky, but I don't think it's usually that picky. So I would round down to 15 on that case. Okay, and then use 15 in the applet. Okay, so we did A, we did B, we've done C, we did B and C with the applet. Part D, he wants to be accurate more accurate than 99% confidence. We want to estimate there's no more than 2 percentage points. What sample size does it need to obtain? So this is a sample size. And then they're telling us use that prior value of p hat. Now, I've done a couple of videos on this, and I know you've seen, I posted at least one. So we're going to use that confidence interval or that sample size formula. And where that all comes from, and I probably have done this on a video, but I'll do it again here, is if I want to find the margin of error, and this is about proportions, I take my critical value of z times p hat times 1 minus p hat over n and take the square root. Now, unfortunately, I don't know n. So what we do is, to get the answer, I'll plug the values in and we'll work backwards, and we'll talk about the formula that Dr. Stevens gives you. I want to be within 2 percentage points of the true value. So my margin of error is 0.02. You could work with percentages if you want. I just think it's easier not to. So let's see. What sample size I need to say? So we know we're going to use our old estimate, and we want to be a 99% confidence interval. So if we look at that normal curve table, and we look at those critical values that Dr. Stevens gives us, it says that one common, the z-score, the critical value for a 99% confidence interval is 2.575. So if I come back to my 2.575, and that's multiplied by the square root. Now we're going to use our 0.15 estimate as a guess. So 1 minus 0.15 is 0.85 over n. So now, without using Dr. Stevens' formula, we're going to solve this for n. And if you remember back to your algebra class, I've got to divide by, I got to work outside in here. 275, we're going to divide both sides of this equation by 2.75 or 2.575. And let's see, I'm going to use an online calculator here. Just a minute here. All right, so here's my calculator. So I'm going to walk through this. I'm going to divide 0.02 by 2.575. The reason I wanted to use this calculator for you instead of writing down a bunch of values is I find that if I'm trying to make WebAssign or some online homework portal happy, or even if I'm trying to come up with a better estimate to match a paper answer, don't round too soon when you're working with percentages or proportions. So I just let the calculator carry all those values. So I am going to write it down a little bit here, just so that you. So when I did that, what did I get? I got, 0.00777. I'll round to. Just 0.0. There was 2 O's, yeah, 2020777, and I'm not going to actually use that value. I'm gonna let the calculator carry it. And the other thing I probably want to do is multiply 0.15 times 0.85. So 0.15 times 0.85. I'm just going to do that off screen, but I will do it on my other calculator. 0.1275 over n. So what I did is I multiplied these two values here, and that's where I got the 0.1275. So now to undo this, I have to square both sides of this equation to get rid of the square root. Because if you square root, so that means I'm going to raise this to the second power, and so I get a very small number. I'm getting 0.000006 equals 0.1275 over n. And this, of course, is over 1, because you can write any number over 1. And then I see a proportion, and as your 7th grade math teacher probably told you, you cross multiply and divide. So I'm going to multiply 1 times that, which is the same value, and then divide it by the 0.000 whatever number. So I'm going to take 0.1275 and divide that by that answer. And of course, these calculators let me grab a value. So I'm getting a sample size of 2,113, but remember, we always have to round up. So the actual sample size I want is 2,114. So that's the answer for part A, 2,114. I'm sorry, for part D. And now, what if we don't have any knowledge of what p hat was? So how that changes is it's the same setup as if we were using the old the 15% estimate. 575 times the square root of, but the difference is 0.5 is our guess of what the p hat is. And if we do 1 minus 0.5, we get 0.5 again. And 0.5 times 0.5 is 0.25. And that's where Dr. Stevens is getting that 0.25 in the formula. So now let's work backwards here, and I'll do the backwards work with my calculator. And then we'll look at those equations, those formulas that Dr. Stevens gave you, because you no need to do all the algebra when they give you the formula. So I'm going to divide 0.02 by the 2.575. And then I have to square it again. So notice so far there's no difference. It's exact same thing we've been doing. But now I'm going to take 0.25 and divide it by that value. Cross multiply, divide. And notice what that does to the sample size. It more than doubles it. Or not, I guess it isn't quite double, is it? But it is a large sample, a much larger sample. So this is why statisticians and researchers will sometimes go out and do a little mini sample just to get an estimate of what the parameter might be using that point estimate, and it pulls down your sample sizes a lot, especially when it costs you money to conduct a sample. So what are we getting? 4145. Don't remember to round up. So 4145. 4145. Now I guess it'd be a good idea to show you Dr. Stevens' formulas, so see how those work, because some of you made a post about those. So I added in Dr. Stevens' formulas from page 212, and algebraically, he came up with these formulas by doing that formula that we did, that I did a minute ago, only just use the values. I won't walk through it. If you really need to see that, let me know. So to find for the first part, for part D, we're going to use the old estimate. P hat's known. So we're going to do the 2.575 is our critical value of Z. So the Z, that's the Z sub alpha divided by 2. So in other words, if we want a 99% confidence interval, alpha is 100 minus 99, or 1%, or 0.01, and then we're going to divide that by 2, and that tells me that the z-score here and the z-score here has 0.05 below it, 0.05 and then 0.99 in the middle, and that adds to 1, right, or 100%. So the formula says square your critical value of Z, multiply it by your p hat from your sample, and 1 minus your p hat is the Q, all over the margin of error squared. And the margin of error they want here is 2 percentage points. So 0.02 squared. So if I fire up my calculator, let's get that out of the way. I'm going to clear. So I'm going to do 2.575 squared. And your Google calculator will do this. Your phone, if it's in scientific mode, will do this. Times 0.85. Then I'm going to hit equals. And I'm going to divide that by the 0.02 squared. Notice we're getting we round up to 214, and that's what I had here. So that saves you from doing the algebra. Now, what about if you didn't know what p hat was, and we did let's see where he's got the 0.25, and that we know where that came from, because we talked about, you're making 0.5 is the estimate for p hat. And I'm just going to get rid of this. I'm just going to write 0.25 here if I can. And on my calculator, let me clear that screen. It's coming to 22.5575. I'm going to square that value. I'm going to multiply it by 0.25. I'm going to divide that by 0.02 squared. And I get the 41.45 if you round up. So that's how those two formulas work. Let's make sure I've answered all these questions. Yep, that's true. That's true. So what would happen, and this is an add-on, but it's what the next question 6, asks you this at the end. What would happen if Carl went out, got a sample of 80 years, and he found out, let's see, what was my interval? I didn't write any of those down, did I? What would happen at the 99% level if Carl went out, picked 80 years of corn, and found that only 5% of them had earworms, had worms in them? What does that say about our estimate? Or what does that say about the old estimate of, let's see, is this using, this is using our 0.15. What does that say about that old sample of where 15 out of the 80 ears had earworms? If we went out and found did another sample of 80 and found only 5 of them had earworms. Well, 5 divided by 80 is 0.0625, which is outside of our confidence interval. So what we'd have to do, how we deal with that is we'd have to think about, well, maybe that one sample was a bad sample, and maybe they got to go out and do another sample of 80 years and maybe do it a couple of times, come up with a better estimate. This is kind of where we're going next week with significance testing. We hypothesize the true center, and then what happens if we get a result that's not inside that range? We have learned ways to deal with that. So that's how you can deal with that kind of question, like number 6 here on the page. Well, I hope this helps. This video is long enough. Give me a yell if you need help. I'll be out at eTutoring on Monday night. This is fall 2017, so I don't know if those hours will stay the same later on.